Experienced backend engineers should skip introductory Python courses and focus on the complexities of integrating generative models into distributed systems. The goal of this roadmap is to reach the level of an AI architect, a role centered on designing, deploying, and scaling production-grade applications. To get there, we are going to follow a 20-phase learning system. This roadmap maps your existing engineering knowledge directly onto the modern AI stack. Applying your existing knowledge of server architecture and deployment to these specific phases allows you to transition into high-level system design without relearning the basics of the development lifecycle. This graphic displays the full multi-layered AI stack. At the top, large language models act as cognitive processors, and vector databases provide semantic memory. Moving down, extraction and embeddings translate raw information into vectors. Finally, frameworks orchestrate data flow, and evaluation tools ensure reliable outputs. Directly pinging an API is simple. The architect's challenge is routing data reliably across all 7 of these complex layers. To master these layers, you need a system to process the information. We will use Notebook LM as your master curriculum engine. You will build a grid of 20 distinct workspaces. You must start strictly at phase 0, which focuses on mental models like attention and context windows, before you write a single line of code. For every new concept you add to a workspace, force the engine to answer 7 specific questions. Ask it how the mechanism works, where its technical limitations lie, and what it takes to scale it. Querying your notes against these strict architectural constraints forces you to stop reading passively. You start actively designing systems in your head as you learn. As you begin coding, you will face a very common trap. Many developers immediately reach for high-level wrapper frameworks to do the heavy lifting, completely ignoring how the mechanics actually work. To build a strong foundation, avoid LangChain or Llama Index during these initial phases. Instead, learn the specific Python elements needed for AI engineering, like asynchronous functions and Pydantic. Then connect directly to the raw LLM APIs to experience how token usage, system instructions, and rate limits function in practice. Apply that same rule to your first retrieval-augmented generation system. Convert the text to embeddings yourself and write them directly into a vector database like Quadrant, bypassing the framework node. When a production system fails, you have to know the raw mechanics to diagnose the error and rebuild the architecture. Once you have a grip on the raw AI mechanics, you can start leveraging the foundational backend skills you already possess. Tools like Kafka allow you to apply asynchronous architectures to manage heavy AI workloads, splitting large batch jobs and document processing through message queues. Your experience with observability platforms like Grafana translates to MLOps. You will set up monitors for AI-specific metrics, tracking token costs, vector database latency, and retrieval precision. System security now requires defending against prompt injection through layers like input sanitization and strict validation. Merging traditional DevOps and Kubernetes with new LLMOps requirements is what defines an AI tech lead. As you approach the final phases, stop building isolated toy projects. It is time to consolidate everything into a single undertaking. Your capstone is a unified enterprise AI platform. You will integrate autonomous agents, the model context protocol, and multimodal memory until they lock into one cohesive architecture. Completing a unified platform at this scale is the empirical proof of your transition. It demonstrates you can handle the complexity of an architect. Your first step starts right now. Open your curriculum engine, initialize your Phase 0 notebook, and spend your first 3 days focused entirely on mental models. The entire blueprint is laid out in front of you. The jump to AI full-stack engineer is a structured system, and now it is simply a matter of execution.